Hello mathematicians. Today we're going to be doing algebraic fractions. That's why the heading is there. And this is something that you've done before. So it's really, I guess, a review of what you learnt last year. Because you learned it so well last year, this should be a cinch. All right, let's have a look. We're now on chapter 5b, so algebraic fractions. You'll find it on page, I'm just trying to find it here, on page 263 of your textbook, so chapter 5b. Let's make a start with this first example, example 6a. You can see that it's a fraction, and for this one, all it needs is simplification. So generally what we do here, and you know how to do this, we look for factors that go into the numerator and factors that, so here's our numerator, here's our denominator. We want to know, and first we'll look at these whole numbers out the front. Is there anything that goes into 8 that also goes into 2? And yes, you guessed it. It is the 2, and 2 goes into 8. I'm going to cross out the 8 and make that 4. And 2 goes into 2 once. Now that 1 really essentially disappears when we go to provide the solution, but I'll put a 1 down there. We know that the other common, I guess, pronumerals, now that we've taken care of those numbers, we can see the common pronumerals, and we have an a down the bottom, and the 1a will cancel with one of those at the top. So this 2 that is above the a there, indicating that's a squared, I'm going to cross that out, and it really gets replaced with a 1. I'm not going to draw the 1 in there in this case because I'm running out of space, but we don't need it, as you know. Okay, and there's a b up the top here, as you can see, but there's no b's down the bottom in the denominator, so no, we can't cancel those out. So what are we left with? Let's go back and let's have a look. So we've got that 4 that's up the top, so let's write in the 4. We also have 1a, we have 1b, and down the bottom we've got 1. Now, in reality, I could simplify that a little bit further and take the 1 out from underneath, and we have an answer of 4ab. I'm hoping that that makes sense. It's something, like I said, you've done before. Now, question B over this side here is a little bit more difficult. Some of you will be tempted to cancel perhaps this top 3 in the numerator with the bottom 3 in the denominator, but you cannot do that. Cancelling only happens when you've almost purely got multiplication happening in the whole term. In this case here, we've got that subtraction there in the middle. So we're going to have to do something like that. We're going to have to convert it into a form where we've got multiplication up the top. And one of the first places you should look for a problem like this is to factorize the numerator. Okay, factorize numerator. And you know that factorizing the numerator means that we place it in brackets. We find a common factor between these two top terms. And so let's go ahead and do that. Our common factor will be 3. You'll notice that there is no pronumeral that is common between both of those. It's just a number, so I'm going to pull out the 3. You've done factorizing before. Open brackets. If I take the 3 and divide by 3, I'm left with 1. Subtract, the minus still belongs in the middle. Now I divide my 9x here by the 3 that I've pulled out. You know that expanding is all about multiplying, but factorizing is about dividing. So we're going to divide the 9x here by the 3. And if we do so, then we end up with 3. So 9 divided by 3 is 3. And we're left with the x there as well. So we've factorised the numerator. We still, however, haven't simplified. We've got a denominator of 3. Okay, now it should be clear to see that we can cancel. And you might say, Mr. Kunz, a minute ago you said that if there's anything else but multiplying in there, you can't cancel. But here we've got the 3 out the front that is multiplied to the rest of the term here. Okay, here I've got a 3 down underneath in the bottom, and we can cancel both of those out. So our expression is left as 1 subtract 3x, because we've cancelled the top numerator 3 with the denominator 3. I'm hoping that makes sense. You can check the textbook if you want to see how they worked through the problem. Okay, let's go to example 7. So over the page, I've pre-written them up there. You can see them there. We have the first one. Now, these are starting to look a little bit more complex. However, don't be afraid. Multiplying fractions is one of the easiest things that you can do. So let's have a go at this. And example 7a, we're going to multiply both of the numerators together. So these two guys we're going to multiply, and we're going to multiply the denominators together. You could be tempted at this stage, and I know there will be some amongst you, to think about cancelling even right now. Now, go ahead and do so. However, I'm going to take the long roundabout way. It does mean that I'll need to simplify later on. If you feel like, and you could, cancel this 2 with that 4, go ahead and do that. All right? But I'm not going to. Here we go. So multiply the numerators. So I end up with 2, and I didn't want to write very well, did it? 2, and I'm going to leave the a plus 2 in brackets, all a bit clunky, over 4a. My next step, and again, there are a number of ways that you could solve this. If you wanted to, you could cancel my 2 here with a 4 there. So there's a second opportunity. Again, I'm going to do that right now. So I'm going to simplify the 2 with the 4. You can't simplify this a with that a because it's linked with a plus to the other part of the term. So you can't do that. It needs to be a multiplied by something if you're going to simplify that. So you can't do that here. Let me then go forward and simplify. So there's 1, 2 in 2. There are 2 2's in 4. So I stick a 2 down the bottom. And so I'm left with an expression, and if I've taken this 2 away in here, and I'm going to scrub it out, then it means that I can get rid of these 2 brackets that I've drawn in here. So I'm left with a plus 2, it's not writing very well, is it? A plus 2 on 2a, and there is my answer. Okay, let's move on to the next one. I'm hoping that you understand that one. This next problem, we have a division. Now remember that we're dividing fractions, and there is a general rule I always like you to remember when you're dividing fractions, and that is to flip and multiply. I'm going to write that in there. Some of you learnt that last year. Flip and multiply. All right? Dividing fractions. Every time you see a division of fractions, please flip and multiply. And you should remember that it is the second term in here, that's the one that you flip, and then you change the division into a multiplication. So let's have a go at that. I'm going to rewrite the problem as a multiplication problem. 2x minus 4 on 3 times, so there's my multiply, 6 on x minus 2. Now for this particular problem, I'll just tidy up that x, I am going to simplify part of this problem at this point. All right, so I'm going to simplify, and it's like the last problem over on this left-hand side. There was the 2 and the 4 that I could have simplified. This time in this problem, I'm going to simplify the 6 with the 3. So 6 as the numerator and 3 as the denominator. Let me do that, because it'll make it just that little bit simpler as we go to simplify later. So there are 2 3's in 6. There are 1 3's in 3. And now I'm going to go ahead and multiply the numerators and multiply the denominators to get, again, I'm going to use brackets in the numerator, 2x minus 4. And underneath, I've got x minus 2. Yeah, okay, so there's another step that we can go through here. I'm trying to think of the easiest way to do this. Now, for many of you, you would say, look, this is it. This is my answer. There's nothing more that I can simplify, but there is. If you can see that there is a pattern between the x minus 2 here, and you'll know that there's really the 2x minus 4 is 2 lots of x minus 2. So what I'm going to do, and I may lose some of you with this, is to expand the numerator. So I'm going to expand xb, and then I'm going to this is a bit tricky. I'm going to refactorize. So let me expand that top one, and I get 2 times 2x, which becomes 4x. and 2 times 4, which becomes 8. So subtract 8 because the minus stays there. And it's all over x minus 2. And there are 2 more steps. I'm going to bring this all over here. I've got a little bit of space. I'm going to factorise the numerator there, and the common factor is 4. So 4 goes both into the 4 and the minus 8. We're really wanting another factor to be generated in here that is the same as x minus 2, and you'll see how that happens. All right, so factorising here, I take the 4 out of the brackets, and if I take the 4 away from 4x, I'm left with x. It's all a bit wonky. And then if I divide 8 by 4, I get 2, and there you'll start to recognise a common factor between numerator and denominator, and our denominator still remains x minus 2. And my last step will be to cancel these two, and really I could stick that in brackets, and these two things look exactly the same. And again, you're going to say, Mr. Coons, you can't cancel those things, but as a package, the whatever's in brackets here is multiplied by the 4 out the front. So if it's linked by a multiply, then I can cancel. So that's what I've done. Cancel the bottom one here. Yeah, scribble it out there. And we're left with the 4. We could say it's 4 on 1, but I'm going to say that our answer is actually 4. Fully simplified, our answer is 4. Okay, a bit trickier, that one. There's 3 or 4 steps that we had to go through to get the answer with that one. I hope you can follow it. Have another look at it and look at my explanation. You can rewind this video if you need to see it again. Let's go to the next page. Whoops, I did that one wrong. Let's go to the next page, and that it is example 8. And you'll find example 8 on page 264 in the textbook. I'll go through it here. This one should be a little quicker than our last one. Some of you are not going to like this particular example because it's addition and subtraction of fractions, and that's one of the more difficult things that you need to do, because if you'll remember, you need to have similar denominators to be able to add or subtract. So we have to make these two terms in this expression with the same denominator. So you can see, and I'm hoping that you're seeing that this 2 here, if I double that 2, it becomes a 4. But whatever I do to the denominator, I need to do to the numerator. So let's multiply this whole term by 2, and then we will be able to subtract them because we'll have a similar denominator. That's the route that I'm going to take. So my first term here, or the 3/4, remains as it is, and I'm going to multiply the numerator, which is the a, by 2, so I get 2a, and the denominator by 2, and I get 4. I could have just written up here times 4. You've seen me do this before, times 4. Whatever I do to the top, I do to the bottom. So now both of our terms in this expression have the same denominator. We can subtract them. Okay, so I can then take the path of going, it is now, I'll collect my numerators together. 3 subtract 2a. Subtract 2a, and all of that's over 4. And that, in fact, is our answer. You'll notice that there's nothing that we can cancel. You may, again, be tempted to want to cancel the 2 here with the 4, but you'll see that the 2 is still linked to the other part of the term here with a subtract, not with a multiply. Sure, it's 2 times a, so we've got a multiply in there, but there's still a subtract in the middle here, so we can't cancel with a 4 at the bottom. So that's our answer. Okay. Let's have a look at part B. You'll notice the denominator here is a 5 and an a. And that's a little more tricky again because one's a number, obviously, and the other one's a pronumeral, but we need the same denominator. Now, in situations like this one here, the easiest way to get a common denominator is to multiply all of this term here by the denominator on this side, and then multiply all of this term over here with the denominator that's on this side. All right, so we're going to go down that path. I'm going to take the a and I'm going to multiply all of the 2/5. What do I get? I get 2a on 5a. Seems simple enough if you can read my a's. All right. And then I'm going to take the 5 and I'm going to multiply everything on this side by 5. So I get, and I'm just going to go straight to 15 because 3 times 5 is 15. All over the denominator of 5a. All right. Have another look at that process if you're not quite getting it. But what we've done is we've taken the denominators and we've multiplied the other term, the whole other term, with that denominator. But now that we've got the same denominators, we can add these two. So I'm going to add the top line, 2a plus 15, all on 5a. And again, that is our answer. All right? Okay, so a little bit of trickiness there just because we need to achieve a common denominator. But once you're there, it's not difficult going forward. All right. Now let's go on to example 9, which I believe may be our last example. It is also our longest working example. So I've got 9a on this page. We'll need probably most of the page to work through it. Okay, here we go. You'll see firstly that we have different denominators, okay? So we're going to have to create a common denominator. And as you can see, and you've done fractions before, the denominator that we're after is 2 times 5, isn't it? So it becomes 10. You'll find that our denominator becomes 10. But in the way that we have to do that, again, we're following the last process. We're taking the denominator from this term and we're multiplying all of this side by the 5. So let's do that. Yes, let's do that. Okay, so I'm going to go 5. It becomes 5 times x plus 3. All right, so I'm not going to expand it out quite yet. That'll be our next step. All on 5 times 2, which becomes 10. Notice all I've done is I've taken the 5 and I've multiplied, so multiplied all of this side by the 5. Now, similarly, now that was a plus in the middle, I don't want to lose that. Similarly, I'm going to take the 2, the denominator from this, and I'm going to multiply this whole side. So I get 2 lots of x minus 2, all over 2 times 5 is 10. So there's our common denominator of 10. What I'm going to do at this point is I'm going to expand. We know our denominator is 10, so I'm going to put everything over 10, but I'm going to expand each of these terms one by one, and I'm going to put it above this line. All right, okay, so let's start with that. We've got 5 times x, 5x, well done. 5 times 3 is 15. There's a plus in the middle there, so I'll make it 15. We've now got the plus here in the middle, so I've just brought that one down there. And I'm going to expand the other side. So 2 times x is 2x. And then I've got 2 times minus 2. Remember to collect the minus 2 in there. 2 times minus 2 is minus 4. Okay. From here on, we're going to collect like terms up the top. Let's see how this goes. I'm not sure where this one's going to end, but let's collect like terms step by step. So we've got our 5x, we've got a 2x, and so in total we have a 7x because there's a plus in between that plus there, okay? We also have 15 subtract 4, and most of you will know because you've graduated from primary school that that is 11, all on 10 as the denominator. Okay. Now I'm looking intently at this because I'm looking for things that we might be able to cancel down, but you can see that 7 is a prime number, 11 is a prime number, and 10 is not a prime number, but it won't go into any of the others. All right, so that is our answer. Okay, wasn't as difficult as I thought. How about you? One very last question. Let's go on to example 9b, and you find this on page 265, at least the solution on page 265. Let's have a go at this. Again, we have denominators that are not the same. These ones here, we need a common denominator. And the easiest way, as was with the last problem, is to multiply this term with this term, which is going to be crazy, to produce a common denominator. Let's have a go at it. We don't need to expand once we've done that, although that is a skill that you should know. Let's have a go. So we know that so I'm going to take this denominator, I'm going to multiply this whole side by that denominator. Let's do the 3 up the top first. So equals 3 lots of x plus 2. Okay, that should make sense. Over, and look, I'm going to make a total common denominator line here. We know that our denominator for both sides is going to equal x minus 6 and x plus 2. It's going to happen on both sides, so I'm just going to go ahead and write it underneath now. Okay, now what I'm going to do is I'm going to take this denominator and multiply this whole side here by that denominator. So I get the minus 2 lots of x minus 6. And it's minus 2 lots because there's a minus 2. We're multiplying that minus 2 by this whole denominator here. Okay. The next step that we've now got to do is we're going to expand the numerator. So the numerator at the top here will expand both of those terms. Again, this is not difficult. You've done this before. 3 times x and then 3 times 2 becomes 3x. That's a bit messy. Plus 6. And now the thing to watch out for, this is the trickiest part of all of this. I'm going to choose a red coloured pen. We've got this minus here, and then we've got another minus in here, and we do need to be careful of that. That's made it rather messy, hasn't it? Let's have a look. I'm going to go minus 2 times x. And minus 2 times x is minus 2x. And I've got the minus 2 times the minus 6. And you know that a minus times a minus is a positive, so I'm going to put a plus. And 2 times 6 is 12. And all of that is still over our denominator of x minus 6, x plus 2. All right. One of the last steps is now to collect the similar terms in the numerator. We've got the 3x here. We've got to subtract a 2x from minus 2x gives us an x. And I have a plus 6 and a plus 12, which you know to be plus 18. And all of that is on our denominator, which we're not going to expand out. X minus 6, x plus 2. I wish we were expanding the bottom there. You've done that before, and that would be a little bit of fun. Do you want me to finish off doing that? Maybe we should, maybe we shouldn't. Okay, so that's our answer. I'm just going to put this in here. If you think you've tuned out already, then you can stop the video right here, but I'm going to expand that denominator because I haven't done it for a little while and you guys haven't done it since last year. So here we go. So I'm going to take that over here and I'm going to say my numerator still is x plus 18, but then I expand my denominator. And you'll remember that I take the x times this x, then the x times the 2, and then I'm going to go minus 6 times the x and minus 6 times 2. And I end up with, I'll do the first one first. So the x times the x becomes x squared. So do you remember what these are called? Yeah, quadratics. X times the x, and then the x times the 2, and that's plus 2x. And then I've got minus 6 times the x, that one just here, minus 6x. It's not hard, it's just following the process. And minus 6 times the 2 becomes minus 12. One last step would be to join or collect those two terms because they're similar together. And so my final answer, if we did want to go down this path, is x plus 18, which is still what we've got at the top, all over x squared. And then we've got our plus 2x and subtract 6x, so we've got minus 4x minus 12. Look at that, isn't that beautiful? That's why we do maths, just for stuff like that. Okay, I'll leave you with it. Please work through exercise 5B, all of the left-hand side questions. That will give you plenty to do. And because some of you consider this material reasonably hard, I think that's probably enough for these 2 periods that you've got. Okay, over and out. See you another time.